Hello, welcome to Open Source CNC. Here we create toolpaths in FreeCAD and Blender and we turn them into real objects on the CNC. Today I'm going to show you how to engrave a nice text, but you can engrave any graphics using the 4th rotary axis. And even if you don't have a 4-axis machine, watching this video will help you understand how to set up the V-Carve operation, will help you learn a few tricks about the operation in order to get great results every time. Plus you will see the CNC in action, V-carving the text on the cylinder, just in case you needed a new reason to get this add-on for your machine. Before moving to FreeCAD, I want to thank everybody that's supporting me here on YouTube by subscribing to my Patreon page, where you also get to watch all the videos without any interruptions, without ads, or more recently on my Ko-Fi page. I was really impressed by the amount of support that I received when downloading the macros used in the last video, so I really needed to shout a huge thank you to everybody. As always, if you want to take a closer look at the file that we created today, in the description of the video you will find the download link where you can download it for free or together with a small donation. I'm using FreeCAD 1.1 development version, which probably will soon turn into the stable version. In this video I'm not going to use the part design workbench, instead I'm going to switch to the part workbench, where I can easily create a cylinder because that's all the geometry that I need. Clicking on the button will create it in the tree with the default values. I need to change the radius to 20 millimeters and the height to 150 millimeters. Now zooming out, you can see the cylinder sitting on top of the XY plane. I'm not going to rotate it from here, even though it would be pretty easy in the data tab under the placement properties or through edit placement. Instead, I'm going to show you how to position it directly in the job in the CAM workbench. But before going there, let's go to the draft workbench to create the text. Make sure you're not using the text tool, instead you need to use the shape from text, the shape string tool. If I move my mouse over the 3D view, you can see the coordinates moving around, but I'm not going to use any coordinates. I'm going to set them all to 0. I'm going to use a height of 12 millimeters for the text. The value of the text value itself is the text that is going to be appearing on the screen. In my case, I'm setting this as open source CNC. Make sure if you by mistake move your mouse over the 3D view, these coordinates will reset. You have to click this button or set them manually to 0. The font file is still selected just as any other file. You don't have any preview, so make sure you know what file you're selecting. I'm going to select this file, which is a script file. It looks very nice and is ideal for V-Carve engravings. They look really well in the end. Click on the open button, again reset the point, click on OK, and our text should appear here right below the cylinder. Press G then R to hide the grid from the draft workbench, and let's go to the CAM workbench to make the toolpath to V-Carve this text on the cylinder surface. In the CAM workbench with the two objects, let's first mill the cylinder out of a square block. I'm going to use a square block of 41 by 41 millimeters, which should be enough to get this 40 millimeters in diameter cylinder. Usually I create all the operations in just one job, but today we're going to have to make it a little bit different. We will have to create a job for each of the two operations, one for milling the surface of the cylinder and one for making the V-Carve. I will show you in a couple of moments why we need to do that. Taking things one at a time, let's select the cylinder, create a new job, click on the OK button to open the dialog, and let's position this object. Of course, you could use the method that I've shown you in a lot of videos by selecting the model, going to edit placement. You can find a video about that method that always works, but let me show you how to use this menu here. Select the vertical line of the cylinder and click on the X-axis button. What this does is aligns the object, the selected object, with the X-axis. In this case, this line, it's along the cylinder. I want the cylinder along the X-axis. This is the way my machine is set up. If your machine is set up different, let's say you're using the B-axis, just select that line and click on the Y-axis. Let's set it back to the X-axis for my situation. Let's click on the refresh button for the stock. And now let's set the origin. In many of my videos, you've seen me setting the origin by selecting one of the corners, but since this is a rotational job, I will have to set the origin in the center of this face where I don't have any vertex. Well, it doesn't matter because FreeCAD offers us a very convenient solution. I can select the face, click on the set origin button, and it will set the origin in the center of that face. Let's go to the Tools tab to set the toolbit that we are going to use. Click on the Add button and select the end mill, in my case the 6mm end mill. If you don't have the toolbit in this list, in the already populated list, here's a video about how to quickly add a toolbit into FreeCAD based on a predefined shape. You need to know that the custom toolbits for now don't work with a 3D surface, so adding them to this kind of operations is really useless. Click on the Add tool and let's add some speeds. Because I'm just going to make a rough shaping of this cylinder, I'm going to use a high speed of 3000 mm per minute, both on horizontal and vertical, and a spindle speed of 20,000 RPM. After that, I select the default toolbit and click on the Remove button to have a clear list here only with the toolbit that I use. Go to default values and set the horizontal and vertical rapid speeds, which are set by the machine. These are the top speeds that your machine moves at when using the G0 command. Click on the OK button to close the job edit, and we will handle the file output after creating the operation. Because we are just going to mill the outside of the cylinder, let's hide the shape string so it doesn't bother us. Let's go to the job, click on the round surface and click here on this little icon where you will find the 3D pocket, 3D surface and waterline. If you don't find them here, here is a quick video about how to enable them since they are experimental and aren't available in the default install of FreeCAD. Select the 3D surface operation from here, and now let's set all these values in order to get what we want. Make sure the tool controller is the one that you need in case you have several toolbits for the job. The first thing that I'm going to change is the scan type from planar, set it to rotational. Leave the drop cutter direction as X for now, just change the step over to 50%. Let's click on apply to see what happens, and I will explain you what I still need to change in order to get good results. As you can see, I have passes with a 6mm toolbit at 3mm difference one from the other. This means that this won't be a perfect cylinder, but instead it will have steps. I don't want that, so let's change it. Using a much lower step down would mean that those steps are almost imperceptible, but that means a lot of time. Let's find a quicker solution which will give us great results, and that is changing the drop cutter direction from X to Y. Let's apply the settings again. I use these methods for roughing out the stock, and only then I create the operation that I want in the end. If you want, you can also set a depth offset. Let's set a depth offset of 2mm and click on the apply button. This is really useful when you want to make a roughing pass and only then use a finishing pass with a much tighter step over maybe a different toolbit, depends on the situation. Let's set the depth offset to 0mm, let's leave it as it was by default, and the cutter will run right on the face of the material. But I will run into some problems. Let me set left view. You can see here that the distance from the corner of the material to the face of the object is really high, probably around 10mm, which in a lot of situations will damage the toolbit, lock the machine and so on. The solution to this, unfortunately, isn't using multipass, because using a multipass and a step down, let's say, of a third of the tool diameter, almost locked my computer, it barely moves. Let's fix this, let's just leave it as single pass and I will show you how to simulate a multipass operation. Let's set a depth offset of 5mm, let's say we want a 5mm step down because we are just going to mill the corners, not the entire material. You can see now that I have a much smaller distance here, so probably everything should be okay. Click on the OK button, open the operations group, select the operation, and click on the copy operation button. Double click on the copied operation and change the depth offset to 0. Now I can close this one and I will have two operations. First one to remove the corners, the higher material, and the last operation, let me just rotate the view, to get the exact shape that I want. Now that we've set the operations, let's double click on the job, go to the output tab, make sure the processor is the correct one for the machine. In my case, GRBL is the machine that I'm using. I can set a file name or just click on OK. Select the job, click on the post-process button, and after clicking on the OK button of the Gcode inspection, it will ask me where to save the file. So now that we have exported this part of today's project, let's go to the machine and turn this rectangular shape into a cylinder. We are now back into FreeCAD. We have the cylinder. We want to make a V-Carve on that cylinder that will follow the surface exactly as it should. Let's first hide this job and let's create a new job for making the V-Carve. I told you that I'm going to show why can't you create everything in just one job, and that is because when creating rotational 3D surfaces, it will take into account all the models in the job. So no matter if I select a face or I don't select a face, you will see a warning that rotational 3D surface ignores the selected faces. That is why we need to create a different job where we can add in the model group, in the models of the job, we can add the shape string too. And we are going to do that first. We are just going to select the shape string and this will help us position it. Create the new job, click on the OK button. Remember, don't select the cylinder yet. Let's go to tools to add the VCARVE toolbit. I'm going to use a 90 degrees V toolbit. Again, if you don't have the specific toolbit that you are using, check this video about creating a toolbit in FreeCAD using a predefined shape, because the V-bit is a predefined shape. Click on the Add Tool button. Let's set the vertical, the horizontal feed speed, the vertical, and the spindle RPM. And let's remove the default toolbit. If we take a closer look here, we can see the origin is really not where we want it to be. Let's solve it really easy. Going to the Setup tab, I have this extension set 1. As long as they are both equal, I don't really care. I want to set the origin, if I set a left view, exactly in the center of this stock. But I cannot select the line, I cannot select anything here. How do I select the center of this stock? With a task, with a job edit open in the tasks panel, switch to the model tab, open the job, click on the stock, go to the view properties next to data and change the display mode from wireframe to flat lines. Now I can go back to the tasks tab, select this face and click on the set origin button exactly as I did with the cylinder. The origin will be in the center of this face. This means that the axis will be exactly at the center of this whole text. Now that we've set the origin and the text where we want, almost where we want, but now let's add the cylinder. It is really useful for setting the heights, so go back to the General tab, click on the edit under the model, and open the solids, select the cylinder, press on the OK button. Again, the cylinder is placed vertical just as the original. Go back to the Setup tab and select the line of the cylinder, set it along the x-axis. But now you cannot, because the stock, which is automatically turned visible, is standing in front of the cylinder. Let's go back to the model, select the stock again, make sure you are in the View tab, and change back the display mode from flat lines to wireframe. Now I can go back to the Tasks panel, click on the line, click on x-axis. Now the cylinder is positioned exactly as I want. Click on the refresh button for the stock. Just in case you have the cylinder somewhere else, its origin isn't coincident with the origin of the job, let me just select the cylinder and move it around a little bit so you can easily see what I'm talking about. So let's say the cylinder after rotation is somewhere random. Select this face, but instead of the method that I generally use, clicking on the set origin, which would make this text run around the screen, let's click on the move to origin. This means that only this object will be moved to the already defined origin. Now I will close the job. I've added the tools, I've set everything up. Well, almost, because I haven't set the default values for the rapid speeds. They are purely informative. I could have created the job without adding values here. These are only useful for calculating the total time of the job, so there's no need to always change these values if you don't need to know the total time before running the operation. Click on the OK button, and now let's modify this text. Let's set a side view, and let's move the text right on top of the cylinder. Let's go to Model, select the shape string, and since it is in the origin and I have a cylinder with a 20 mm radius, let's go back to the Data tab. The view remained active after modifying the stock. Go to Placement, Position, and set the Z value to 20 mm. You can now see that it sits right on top of the cylinder. A safer way, if I later change the diameter of the cylinder, would be to edit the expression and write here cylinder dot radius. In our situation, it gives exactly the same value, but if later I change the diameter of the cylinder, the text will move automatically. What I don't like for now is the fact that the text starts right from the end of the cylinder. Let's move it 15 mm to the right. Again, select the shape string and change the X from 1 to 15 mm. Now let's select the shape string, click on this little arrow and select the VCARVE operation. As usual, the first thing that I do is click on the apply button to see the initial results, and I will click somewhere else to avoid having the text highlighted and blocking the view. The default VCARVE settings are not what I'm looking for. You can see that I have a lot of up movements here, just as if there were corners here, but I don't have any corners. It happens for the entire text. Let's fix that by changing the filter collinear lines from 10 to 80. Now if I click on the apply button again, you can see that the toolpath is much cleaner, it looks way better and is pretty close to what a VCARVE operation should look like. But taking a closer look, you can see that it's consisting of some straight segments which will really look ugly in the end. To fix that, we need to change this value, the discretization deflection. I will set it to 0.01. Click on apply again and you will see how this line will change from this rugged line to this perfectly rounded line. The last value that I'm going to change, you can see I have some up and down movements here, some useless up and down movements. Let's check the optimize movements checkbox, click on apply again. And now I've removed most of those useless up and down movements. I think we can work with what up and down movements are still there. Click on the OK button and now let's do the magic. Let's turn this flat Gcode, well, almost flat, it's a V-Carve of course, but let's make it follow the shape of the cylinder. To do that, select the operation, go to the CAM menu. Well, you have the dress ups here, but this little arrow is pretty difficult to click on, especially with this large yellow mouse that I'm using so you can see better. So I prefer to go to the menu, CAM, Path, Dress Up, Axis Map. Set the radius equal to the radius of the cylinder, 20 millimeters. Leave the axis mapping from Y to A. If you're using the B axis, change it to X to B. The way I set things up are along the X-axis, so I'm going to use the Y to the A axis mapping. Select the job, click on Post-Process, inspect the Gcode, click on OK, select the file name if you haven't entered it in the job details, and we are good to go. We can go to the machine and see the text V-carved on this rounded cylinder. Thank you all for watching. I hope you learned something useful today, or that you were at least impressed by what FreeCAD can do. Again, thank you everybody for all the support. See you next time for the next video.